Hi friends, welcome to follow up. Let's have a look at problem 2272, substring with largest variance. In this video, we're going to explain a solution based on the Kadane's algorithm. So essentially, Kadane's algorithm is a form of dynamic programming. So first, let's look at the problem statement. So here, first paragraph is a definition, so the variance of a string. It's defined as the largest difference between the number of occurrences of any two characters present in the string. Note that the two characters may or may not be the same, but also we want to comment that if the two characters are the same, then the variance induced is 0, right? But here for this problem, we want to find the largest one, so we cannot just consider the same character for sure. So given a string S consisting of lowercase English letters only, return the largest variance possible among all substrings of S, right? So a substring is a contiguous sequence of characters within a string. So here we have two examples. In the first example, we see that, let's look at this string. So this one, we have 4 B's and 1 A. So 4 minus 1, that is 3. So this is also the output for this example. So for the second example, there are 5 unique characters in the string S. So if we use one minus the other, so the occurrences are all ones. So the output is 0, right? So you can even consider the same character, right? AA, right? It also yields 0. So this example 2 actually is very special. The constraints for this problem are the following. First, the length of this string is bounded above by 10 to the power 4. So this is a decent large number, but not that large. So S consists of lowercase English letters. So this is very crucial for this problem. Essentially, we can consider any pair of lowercase English letters. Then we compute their frequency difference, right? Then we find the largest one. That would be the return for this problem. So this is also the hint, right? So think about how to solve this problem if the string contains only 2 distinct characters, right? So then let's see, we assume that there's only 2 characters. So we replace the one by +1 or the other by -1, right? Then we just need to find the largest contiguous sum. So this is nothing but Kadane's algorithm. So hint 3, try find the optimum answer by taking all possibility pairs of characters into consideration. So this is also what we want to do in this problem. So here, first, I'm going to write a utility function. So here, I'm going to write as Kadane. So here, it accepts 2 characters. Let's see, A and B, right? Also, it accepts the string S, right? So we want to return an integer, right? So we assume that A is a character with larger frequency or larger occurrences, character with lower frequency. And then what we are going to return is the frequency of A minus frequency of B. So this will be an integer. So this is our plan. So in this case, we need to pay attention to the problem, because here we are not only just finding the largest consecutive subarray sum. Basically, we want to make sure the sum involves 2 characters, right? So now let's first look at the problem logic. So first, I'm going to initialize an answer that's to be 0. So this is the smallest possible, right? Non-negative. And then we have a count for A, initially 0. Count for B is initially 0. So now we're going to traverse this string S, right? So as hinted by the problem, if we meet an A, so we're going to count it as a 1. If we meet a B, we're going to count it as a -1. But the final difference must have at least 1 B, right? So this is our consideration. So for this, we can also extend previous B, right? So we want to include this B. This is the row of this flag variable or Boolean variable. So next we're going to do the scan. So for character in S, then if character is not A, add character is not B. So in this case, we just continue, right? So then if C equals A, it means that the larger frequency 1. So we're going to do count A incremented by 1. If the character equals B, so there we are going to do count B incremented by 1, right? So then what we want to consider is the difference of count A and count B, right? So now let's see, if count B is greater than 0, indeed it means that it includes a B, right? So then what we are going to do, so we want to relocate during the process one substring containing both A and B, right? So we are going to update the answer to be max answer and count A minus count B. So this is one case. Another case is that if count B equals 0, but we can extend using a previous B, right? So in this case we want to check if I can extend previous B. So in this case, if this is true, then we can update the answer to be the previous stage. So now we have this number of A, count A in this window, but there's no B, but we can use a previous B, right? So we're going to minus 1. So this is the case. Other case, so if count B is greater than count A, in this case we are going to reset count A equals 0, count B equals 0, and can extend previous B to be true. So this is the overall logic. So now we are going to return the answer. So this is the condensed algorithm, right? But you can think of this like if you meet an A, you have the list. Think of like this list, right? So let's say we have a list, aux list. So if you iterate over for character in S, if C not in A and B, right? So aux, so we just append a 0, right? Otherwise, if C equals A, right? So we're going to append this one by positive 1. Otherwise, so we're going to append by a negative 1. And then this procedure corresponds to compute the maximal possible consecutive subarray sum for this aux. But it's slightly different because we need to consider both in the window we need to consider both A and B. So this is the utility function. So with this main work done, what we want to do actually, we just return the max of the possible pairs. So this is self-Kadane. So character 1, character 2, S. So for C1 in the lowercase letters, right? That is string ASCII lowercase. And then for C2 in string Simpson ASCII lowercase if C1 does not equals to C2. If these two are the same, then we are going to get 0, right? So with that said, we are done the main coding part. Now let's do a test. So here type error not supported between none and integer. So this line 4, right? So let's see. We can let's see max for C1 in lowercase. Let's see. I guess there are some problems. So here for max of this, for this, let's test again. If C1 does not equal to C2. Let me write like this. So result equals 0, right? So let's from string import ASCII lowercase as lower. So basically for C1 in lower, for C2 in lower, if C1 does not equal to C2, then result equals max result self Kadane, and then C1 C2 S, right? Then we return our result. So now let's test again. So here is still not supported. So I see. Let's see. Let me check. Oh, here the return. I guess that's the problem. Now let's test again. Yeah, it passes the first example. So now let's look at the second example, right? Yeah, it passes the second example. Now let's do the submit. Yeah, it passes all the cases. Now let's restore what we want to return. So let's write in a shorter fashion. So use list comprehension. So we're going to return max self Kadane C1 C2 S for C1 in lower, for C2 in lower if C1 does not equal to C2. So in other words, we can write it as just a one line, right? So now let's do the submit. Yeah, it passes all the cases. So here, if you are not very familiar with the Kadane's algorithm, you can check this algorithm in Wikipedia, or you can look at some of my previous videos, which actually covers this application of Kadane's algorithm. So here, a last comment is that, so here the Kadane's algorithm is actually a variant of the original Kadane's algorithm. So with that said, basically that's about it for this video. Thank you.